So let's start with some definitions. We need a reference, a temperature reference. Okay, so we need to look at climatological data, look at the warmest month, and determine from all the years of observations that we have, what is the average temperature of the warmest month in selected regions. So what we do is we use the highest long-term monthly mean value. That's our reference. Once we have a reference, we can say, oh, it is warmer compared to that reference, or it is colder. That's the important thing. Also, the reference has to be based on some long record, say 20, 30 years, and also excluding the more recent times of rapid global warming. So now then we can work out hotspot temperature anomalies, and they are actually defined as daily temperature values, that exceed the climatological mean. So we look at daily values and now compare it with our climatological mean, and we can look at the difference. So what we do in this exercise is we use weekly values rather than daily values. Just to make it a little bit more, to save some time on the calculations, essentially. So the degree heating week now are defined as the sum of daily hotspot values exceeding 1 degree Celsius. So you have originally, so we use weekly values, but originally it's based on daily values. You look at all the days that have a hotspot values that exceed the climatological mean by more than 1 degree. You take that value and you sum it up with other values. All right, so we use weekly data, and we miss some events because we're already looking at an average. So what you should do in this exercise is you should use a lower threshold of 0.75 degrees Celsius to calculate the DHW value. Not 1 degree, but a lower value. And it doesn't matter in the end which value you use, because you actually compare different regions or you compare different years of data. And you can always see it's the difference that matters, not this definition of the threshold value. All right, so let's have a look what we do now. So first of all, we look at the Great Barrier Reef, temperature distributions, and how do you select two different regions? And it looks tricky initially, but you have to make a decision. Which regions do you choose? And then come the other 3 steps. How do you work out the climatological mean? How do you calculate hotspot temperature anomalies? And how you now estimate degree heating week values. So let's start. Let's have a look. Looking on the map. Let's see what comes on the next slide. I'm not sure about that. Map. These are typical sea surface temperature distributions. And it's not summertime here, but anyway, it's just pick a random month, and you can see the Great Barrier Reef. The extent of the Great Barrier Reef is shown here.